Hello everyone. Very good afternoon to all of you. We'll wait for another 2 or 3 minutes, then we'll start the session, right? Almost every participant is here, only 2 persons I'm waiting for. So just 1 or 2 minutes I will wait, then I will start. Just 2 minutes. My voice is audible. Is it clear to all of you? Yep. Okay. Okay. Can you tell me what was the last point, or you can say what was the last thing that we have discussed? Can anyone tell me the URL that we had used? I guess all of us now joined up, so we should start in a flow. Can anyone tell me what was the URL that we had used? It was chip orders or what? Yeah, chip orders, right? I was missing this thing one day. Okay, okay. It was read table. It was a tabular data. Okay, fine. Okay. So at this point, we had concluded yesterday. Okay, and we had seen some comparison, right? And we had seen some comparison like about chicken. We had seen like how we can compare with a particular word. We had seen a comparison based upon the second one also. Then we had seen the null, how to process the null variable. We can say null data, right? So next thing we are going to see uh, with the item price. Okay, we are having item price, certain item price we are having, right? So this kind of data we will get with a certain item price or certain kind of numeric value. But this numeric value is also having some kind of a symbol that is dollar and all. Is it? So what you can do, you can just use item price. Okay. So you can see this is the item price. Now if I want to calculate some value over here, I want to just put a calculation, some sort of calculation. So what you can do, I can do this thing mean. Okay, but it is showing error. Why it is showing error? Because you can put a calculation, you can do a maximum, minimum, or any kind of things, any kind of mathematical calculations over what, over a kind of a numeric value. But this is not a numeric value. This is what, this is your object. Getting your point? This is your object, right? So basically, if you having this kind of situation, so what we can do, look, yesterday we had seen a function. The function was dot contains, right? Dot contains. This was our function. Okay. Today we will see one more function, dot replace. Okay. So contains function we had seen, that was okay, and then we can see the replace function. Okay. So contains function is used for what? It is used for comparison, to compare a string. Replace function will be used to replace a string, right? To replace a string. This thing will be used, right? So what you have to do? You have to just use dot replace. What do you have to replace? You have to replace the dollar symbol, because dollar symbol is not required. With what? With no value. Execute it. Not executing. Why? Because all of us know with contains we used what? Dot str. Same thing here also, you have to use dot str. Got it? So things got replaced. What got replaced? That dollar symbol got replaced. Now you are having a value that is called simple, but still it is an object. Okay, still it is an object. Now the question, how we can convert the data type. Okay, if it is an object, it is a number, and being a number it is an object, or being a number it is a string, and we have to convert this thing into integer or float. How can we convert it? Look here. With respect to data type, we are having two types of function. One is called d types. Through d types, we basically get all the data types. Data dot d types. What we are getting? We are getting all the data types. And second function is known as what? Dot as type. Okay. Second function is dot as type. What as type do basically? As type is used. This is a function. D types is a attribute. As type is a function. Okay. So what as type will do? As type will use to convert the existing data type. It will be used to convert the existing data type, right? This will be used to convert the existing data type. So that means if you are having a data type that is this one, okay, str dot replace, and that is integer value. So what you can do? Dot as type. What you have to do? Dot as type float, because you can't make it integer because this is a float value. Now convert it. So now you can see it's a float. So what we have seen in this particular syntax, we had seen how to replace a value which is not required, how to replace a particular character which is not of interest dollar or whatever character it is, how to replace this character if it is if it is of not your our interest. And second thing, how to convert, you can say, a particular data type into another data type using what, using float, using as type, and within as type the data type, that is float or whatever you want to do. Okay, thereafter any type of mathematical calculation if you want to do, we can do dot mean, dot maximum, dot minimum, anything we can do, right? Okay, why str? Look, Harshit, str is what, if we are processing over a string type of data, we have to use str. Like yesterday you might have seen, while we have used dot contains, there also we have used dot str. The thing was dot str dot contains. Okay, so this is a format as of now we have to use. In future it might be updated and you are not required to use, but as of now this function is using by picking the data type. Is it done for everyone? Okay, so once you just go through the things, whatever we did yesterday, whatever we did today, if you are having any doubt you can ask. If not, then I will give you a small assignment. Okay, that will makes your concept more clear, and once it is done, thereafter we'll move to the next topic. Okay, we'll work with some real-time implementations, like we'll see how these things can be used in machine learning and all those sort of things, right? Is it working for all of you? Any doubt? Okay, fill na function. Okay, Akhila, what is fill na? Fill na is just like filling a null value, right? Filling a null value. Okay, did not understand d types, I will explain. Fill na is like filling a null value. That means, look here, we are having data. Okay, this is your data, right? In this data there are so many types of datas are there. Okay, so there might be certain point where value is null. You can see over here it is a null value, that means there is no data present over here, that's why it is showing null value. If you want to see it, you can download the data and open the data in Excel file. You will see it will be a blank space. Okay, so the thing is how to find out where are the null values present. We can find out by using dot is null. This will just return all the true, all the true or false. Means if it is a true, that means null value is present over there. If it is a false, that means no null value. Here there is no null value. False shows no null value. Here it is true, that means it's a null value. Now how many null values are there and in which column? How can you find out? You can find out by adding all the true. And how can you add all the true? True represents 1. And how can you add all the 1? By just passing sum. So this will show that you are having a null value, that is 1246 null values are there in choice description, right? Thereafter, if you have to basically compare something based on choice description, then what will you do? You will just, this is your data, right? And you have to generate certain analysis based upon choice description. Suppose you have to generate analysis based upon choice description using this thing salsa. Okay, like you have to just extract all the data which is containing salsa. So how, what you will do, you will use data. Okay, you will define choice description. Okay, CHOI, right? Choice description, right? Dot str dot contains, right? And salsa. Okay, So it will compare the thing and will return two value, either true or false. But with true or false, you are getting one more value, that is NaN, because of null. So as per the concept, if you are having true or false, you can pass that true and false through the data, right, to get a filtered data. Okay, to get a filtered data. Here you are getting a filtered data, but here you are not getting because of null value. So before doing this kind of analysis, we need to treat the null value. So what we will do, over the null value, we will just put any random string. Okay, so how it can be done? Just pick data choice description dot fill na. Okay, means just fill all the null value, and we are filling with what? A B C D E. If we fill any string value, so that particular blank space will be replaced by A B C D E. So if there will be a string, this str dot contains can compare that string. Okay, if there is no string, then it is not able to compare anything, right? So if it is a string, if you replace it, okay, it is showing fill na spelling is wrong, right? We have to give fill na, FILLNA. Okay, and this is done. So you can say all the null values are now filled up with ABCDE, because we don't know what to fill. So we have to fill any string value. So it totally depends upon the condition what you have to fill. For example, in case of numeric value, you can't directly fill any random numeric value, right? In case of numeric value, what you have to do? You have to take care, you have to calculate the mean, average value, or maximum value. According to the condition, you have to fill certain value, right? Here we are filling what? String value, right? Assign to it. So once you assign it, after filling, your data will contain no null value. After that, you can compare salsa, and salsa will be compared with all the string, because salsa is itself a string. So if salsa is present, it will be true. If salsa is not present, it will be false. Okay, so you can see over here, in all the line, this salsa string must be present. Okay, so that's how your null value, or you can say fill na is used. Fill na is used for what? Fill na is used for just to fill up the null values, whatever the null values. Then next question is, Aditya asks fill na, Akhila is asking D types. D types is nothing. D types is just the data types. Okay, data types means what? If your data is having like this, okay, and you don't know which column is containing what data, or what are the types of data, so you can use data D types, that is data types. So it will return that first column is having integer, second is having integer, third is having object, object, and object, right? So Aditya, is it clear for you and Akhila? Okay, 64 means 64 bit, means the integer that is being defined in the first column or in the second column is taking a space of 64 bit. Maximum 64 bit integer it can. They generally we use two types of things. It's a 32 bit or 64 bit. Okay, 64 bit means what? We are using a sign, sorry, unsigned integer kind of a thing. Okay, unsigned integer kind of a thing, it generally represents as a 64 bit integer. It's a memory space, right? Okay, so I will give you some assignment. You will work independently, and then whatever the problems you face, you will ask me. read this data. Okay, after reading this data, what you need to do, you have to do a simple analysis over it. What is the analysis that you are going to do? Let me write over here. Yeah, sending. Got it? So this is a collab link. Okay, you have to read the data first, and you have to just analyze the data based upon three things that I have mentioned. Just three things. Okay, let me tell you, in Python, or can be done. You can compare a or like this. This is for or. Okay, and this is for and. Right, so just apply your concept, apply the learning whatever you learned, and whatever the confusion or difficulty that you are facing, please share with me so that we can collectively solve the problems, right? You have to attempt whatever. If you're trying wrong, if you're doing wrong, then it's okay. If you're making wrong, then also it's okay, but you have to make the attempt, right? You can see you have to do analysis of a star rating, right? So first pick a star rating. I'm just solving the first problem, okay? And you have to compare, and comparison I told you, right? Why it is not working up? Anyone can tell me why it is not working up? Okay, it is in movies, right? That's why it is not working. The data is movies. Got it? So now it's like you are having a star rating over here, right? Now what I told, a star rating greater than 8.5, was it? A star rating greater than 8.5. So comparison part I have told you earlier only. You can just give 8.5 greater than 8.5. Okay. So this is true or false. Okay. And with true or false, what you need to do, all of you know. Okay. If you pass this true or false through the data, what will happen? The data will be filtered. Okay, and you will get all the data that is having a star rating more than 8.5. But we have to add one more condition with it, right? The second condition is what? Oh, sorry. And duration is less than 160. Okay, duration is less than 160. So duration is less than 160. So you have to define that condition also. Movies duration, right? And you have to define is smaller than 160, right? 160 or 170, whatever it's there. So it will return either true or false, right? Next, we have to use both the things together because it is a AND condition, right? So I told you what to do with a AND condition. You can just put over here the bracket, this one, parenthesis, close, and parenthesis open close. Now having true and false, we got it. Okay. So now you can see that the things, it is having all the, what was the thing that I told you? I told you extract all the data with a star rating greater than 8.5 and duration is less than 160. So now you're having that thing over here. Star rating is greater than 8.5 and duration is what? Less than 160, right? So we got it. So out of this, if I know, if I want to know only the movie name, so what you can do? Just pass title. So this is all the title, right? So this is one kind of analysis. Please, all of you try for the next one because this kind of analysis ultimately you have to do for kind of a movie recommendation kind of thing. You have to prepare movie recommendation engine or something like that. Okay, Shreyans, what is wrong in it? It is there is only a small mistake that you are doing. You had given smaller than 160, that's very nice, and then greater than 8.5, that is also okay. But here AND operation is operating between this thing. I have selected something. Just a minute. Let me give you. Let me write your syntax. Then I will explain, Shreyans. I will write a syntax over here, right? And thereafter, actually here AND operation is happening between these two things, not on complete data, not on the your true or false. You know, and or. This kind of operation you can do only with between true or false, right? But here it is not going on true and false. Here it is going on between 160 and that thing. Okay, so that is the issue that we are facing, right? So you have to, what you have to do, you have to put this thing in parenthesis. Got it? This should be in parenthesis and this should also be in parenthesis. Now it will work. Yeah, thank you. Now go with the second part of the analysis. What was the second part of analysis saying? Got everyone? Anyone did it or not? Mm, how to resolve unsupported operand type? Unsupported operand type you are facing. Why you are facing unsupported operand type for? Just wait. Let me check why you are facing this. Just I will give the solution. Just compare your thing. They are saying extract all movie data from genre crime adventure comedy. This thing we need. So actually crime adventure comedy, right? Genre. So first let me check the spelling of crime genre adventure. So it will be like movies dot, or you can say movies genre, GENRE genre, right? Dot unique, right? So this will give me the correct spelling first. Second thing, I got it. Second thing I have to use movies genre double equals. I have to compare what? Crime, right? So just pick the crime thing. Okay. So we'll compare, we'll get what? True or false. Okay. So apart from crime, three things also you have to compare. What are those three things? Adventure and comedy, right? So I'll just copy this thing. Okay. And B and B. So it is like genre. Second one is adventure. You can just put adventure over here. And third one was what? No, just execute again. Uh, it's some kind of a login error or some internet connectivity. So then we got this kind of thing. Like some internet lagging happened. Then it kind of things happen, Aditya. Okay, crime again, execute it. It will work. Crime, adventure, comedy, right? Okay. Actually, I did. Yeah. Okay. So we are what we are doing. We are just comparing this thing. Sorry, it should not be end, right? Because same movie can't be in the this thing, right? Right. It should be or. Okay. So it's like it is there. Thereafter, what you will do? we need, so finally we're getting true or false. So next part is, what is the next part? And star rating more than 8.5, right? After this, you have to compare, and a star rating should be more than 8.5. So it should be like this. I will tell Shreyans what you can do. So it is there. Thereafter, star rating we have to compare. And movies, star rating should be greater than 8.5. Okay. So this is it. Thereafter, you know what to do. Just pass movies. So it's too big, right? So many things we require to write. Okay. So crime, comedy, adventure, star rating, all the things we got. Okay. Greater than 8.5. Now comes the Shreyans thing. Like he is giving this one, but it is not working. Yeah, it will not work. Okay, but there is a way. Okay, it will not work, right? Sorry. It working? I guess it should not work because this can compare only one value, right? But there is a way to make this thing simple. What you can do, you can use a function. The function name is in dot is in, right? Okay, and is in you can pass what? Crime. It was a crime. Second was what? Adventure. And third one was what? Comedy, right? So if there is a single row, sorry, single column you have to compare, you can use is in function, right? It takes two positional argument, but four were given. Okay, so that means I'm doing some mistake with a is in function. Okay, so let me check what mistake I'm doing. I guess it is telling itself the mistake. Can anyone tell me what mistake I'm doing? Okay, I got it. We have to give over here the list, right? This should be a list. So this is doing the same task that we did previously. Okay. So through isIn function, you can compare something if in the same column you have to compare. If the same column you have to use, if the same column you have to use, then simply you can use what? IsIn function. This isIn function can help you to compare. Clear? Done for everyone? Any doubt? If it is done, then please go with the third part, the third thing that I had given. What is the third thing I had given? Extract all movies of actor Robert De Niro. Got it, Sriyans? Whatever you want to do, you can do by using isIn function. Solve the last one. Right, right. Got it. Right, Shreyans. So I hope now you're getting into the picture how it works. Right, Parthiv. So now I'll proceed for the next part. So this is where I am. There are lot many things, lot many analysis we can do, right? It's never ending job. Like there's so many things are there. For example, if I will give you one more example, just a minute. If I'm having that one, okay. Uh, so let me see, like if I'm having the data or not. Okay, it's like okay. So this is a data of Titanic, right? This is a data of Titanic. Got it? Titanic ship. Like the person's name are there, like passenger ID, did they survive or did they didn't survive, the passenger class name, their gender, age, right? And all those things are there, right? Embarked is what? From the point they started, like Southampton for S, C for Christchurch, like that, right? So you can do some sort of analysis over here. If I will tell you to do some sort of analysis, you can do. But if I will tell you to just make a kind of a, you can say program, just write up a kind of a program that can extract the first name, or you can say this particular name. What is this? This is surname. You have to write a program that can extract the surname from the name, and means you have to create a new column. In that column only surname should be there. Okay, so this can also be done through Python. You know, this can also be done through Python, means you can directly extract the surname from all of the data. Whatever the data that you can see, you can extract the surname. Okay, you might be thinking how it can be done, right? So we'll see this thing. Shall we continue, everyone? Anyone needs some kind of assistant? At some point, it's DVMS query. It is like, okay. So at, shall we continue? Yeah. So it's like, this is a small example that I'm giving. There's some, I will give you some kind of a documents in PDF, so that will also help you a lot. So it's like SIP.
you have to put the extraction over name, or you have to do analysis over name. Okay, and you have to extract the name. Okay, name is not working. I guess some other word is there. Okay, capital N is there. And what I told you, we have to extract the surname, right? So how can you extract? Okay, look here. In Python, there is a function named split. Okay, you might be knowing of this function, you might not be knowing. What does split do? With the function split, you can make a split over any string based upon certain reference. Means you can split this string into two item. This string can be splitted up into two item. Okay, and those item will be there in the form of list. Okay, you can form a list of that. Okay, that means it's like it will give you output like this: broad, BRAUND, broad, right? And second one will be what? Whatever, like Mr. Owen, whatever, like, right? Mr. Owen and Harris. So it will form a list. It will get splitted and form a list. Once you get a list, what you can do? You can use the index 0. Okay, because at 0 you are having a broad, right? And broad you have to separate. So the same thing we'll do over here. Name, and on the name we have to do a split. Okay, so just split on the base of what? On the base of commas. It is splitted. Okay, it is showing error. Why? We're getting an error of it. The reason behind is what? Anyone can tell me? It's very simple because we are working on a string, so it should be dot str, just like replace and contains, right? So you got it. We are not getting any change because it is already splitted, but we can't see the change because it is in a pandas series, right? So what you can do, you can pick a first value 0. Okay, so now you can see, as you are picking up the first value, what you can see this thing, right? It is splitted. No, as type we can't use. We use as type and extract. No, no. As type is just for converting a string into integer, or integer into a string if it can be. But here we can't convert. It is a string and it can't be converted into integer, right? Now, if you pass again 0 over here, what will you get? You will get the broad, right? Okay. So this thing you can use. What you can create, you can just create a blank array. Okay, and thereafter for I in will it work for it? Will it work for this? Sip of name. Let's see, is it working for this or not? Then we have to use something else. Okay, it is working over here, right? So what we can do? I dot split, right? So it's a simple Python syntax if you know. Like you can see, I'm not using any kind of a complicated thing. Just a small function I have introduced, that is split. Apart from split, everything is fine. Loop and all things we all know, that I have explained earlier as well. Okay. So it is splitted, right? And thereafter, what I can do over here? 0. You got it? All the surname we are having, right? So this surname we can put over here. How we can put? Instead of using print, I can use surname dot append, right? Surname dot append. So you're having a list. In that list, all these things will be there. And thereafter, this new value can be added to your data set by using SIP surname, right, is equal to what? Surname. So it will be added into a now called SIP. Look how easy it is. Loops are there. Okay, and now you can see there is a new column over here. Okay, and this column is containing what? All the surname, right? So this is how you can do any kind of analysis through Python. If you are having pandas and all, if you're having numpy and all, so any kind of analysis can be done and you can make it happen. The same way, if you did it, then if I will tell you one more thing to do, that will be last assignment for you, and after this we'll go to the next part, that is machine learning thing. If I will tell you, please work open over embarked section, and just what you need to do, you have to map it. Map it means, or you can say, what I should say, mapping, or it is known as encode it. Encode it. Okay, you have to encode it. Encode it means what? S you have to encode as 0, that is Southampton. Christchurch you have to encode as 1, and Southampton, Christchurch, and third one is what? Whatever it is the Southampton, Christchurch, and Queensland was there, Q. And Q you have to encode as 2. You can do it? Just do it. This is the last assignment for you. Thereafter, next thing we'll do. You have to encode it. For encoding, I guess I have told you about the mapping and all, right? You have to, because why we need to encode it? Because for any type of algorithm, for any type of kind of analysis, for any type of working with the data set, you need only mathematical data type. You can't work with a string. If you are having a string, you have to convert the string or object into mathematical by any means. Okay, but you have to work with only mathematical data type, right? So this is called encoding, or you can say categorical encoding. Whenever you are having category, you have to encode it. Okay, so just tell me how to encode it. You can replace, yeah, you can use replace, but replace is something that I will not recommend. But I will tell you what you can do. Look here. First of all, I will tell you when it needs, whenever you have to uh, encode, or you can say you need a categorical thing. So SIP embarked, EMBARKD, embarked, right? Why we need it? Because whenever you are having a categorical value, right, in our data set, we need to map it into what? Mathematical value. Okay, so suppose there are 5 categories. Okay, so you can map those things as 0, 1, 2, 3, 4, 5. We are having 3 categories, right? So you can map them those things as a 0, 1, and 2. Okay, So it's like you can just find all the category by using what? Unique. Okay, unique, you can find out all the categories that you already know, right? So these are unique. Okay, nn is what? Some null value might be there, so you can treat the null value later on. So basically you have to things of this one. Okay, dot map. What you need to map? You need to map these three things. What? S should be mapped as 0. This is called encoding. Then we have a encoding categorical value. This should be mapped as 1. And the third one is what? Q. Okay, mapping of Q is called 2. I hope the syntax, the function is not that much complicated that you have to remember, right? The function's name is like very simple. You can, it is not like you have to remember or something. It's general words are there, right? Still with the practice you also. So you can see it is mapped, right? Whatever things are there, S is mapped as 0, C is mapped as 1, and Q is mapped as 2. Got it? It is getting mapped, right? If you have to store this value somewhere, you can store. If you don't, or suppose you have to store this value in a new column, right? So you can store this value in a new column. How can you store this value in a new column? By using SIP. Okay. Okay. It will be like mapped map embark map emb. I'm showing. So map emb I had given, and now you can see if I call SIP, there will be a new column that will have a mapped value. Got it? So this is it. So this kind of analysis are important. Apart from that, this there are so many things that we can do in analysis part, and in pandas part there are so many things are there. But it's not like that only we have to cover those things. There are so many machine learning parts also you have to look after, right? So what we'll do after this, we'll start with a machine learning concepts and all. Okay, so just read out all the things whatever we did in numpys, pandas and all. Okay, if having any doubt you can ask. If not, then you can proceed. It's 3:15. Can you take a 15-minute break? Will it be good for you before starting machine learning? Yeah, sharing. It is already shared. You have to just, Harshit, what you need to do, you need to just refresh the link. The link is with you. You can just refresh. Got it? It will be better for you. Like, can we get a 15 minutes of break before starting the machine learning concept? Or shall we? Yeah, right. That's it. So by 3:30 we will again start. By that time, just settle down yourself. Just go through the things, whatever the things we learn. Okay, just make the things proper arrangement in your mind. And if any doubt, you can ask. And then at 3:30 we'll start the machine learning part. Okay, I hope we should start back, right? Everyone is ready for the next part? Yeah? Shall we continue? Is my voice is audible to you or not? Shriyans, Aditya, Harshit, am I audible? Okay. So shall we continue? Okay, Parthiv. So we are now continuing to the next part. Okay. Next, we are going to start with a part that is called machine learning, or you can say the main like the first you can say artificial intelligence. Actually, the artificial intelligence and all those kind of implementation where you will see apart from using this whatever we learned, whatever the knowledge we got in data science, whatever the knowledge we got in Python, okay, and whatever the different things that we learn, okay, so based upon those learnings, based upon those things, now we are going to deploy, or you can say create a machine learning kind of a deployment, right? So how it can be done, okay, so those things we are going to see now. Look here, if I consider machine learning, then machine learning basically divided into, as we start with it, we generally consider machine learning in three types, right? What are those three types? First of all, first we divide this thing, we call it as a supervised learning, right? Supervised learning. Second thing we consider that is called unsupervised learning, right? And third type of machine learning is known as what? Reinforcement learning. Okay. So these things we consider. Okay. Whenever we start working with ML, we first know about how many types of machine learning possible and what are the different ways in which a machine can learn. Okay, like we learn in different ways, right? Like online learning, classroom learning, self learning. There are so many ways we learn. The same way machine learns in different pattern. Okay, it can be supervised, it can be unsupervised, or it can be reinforcement. Okay, so one by one we'll see these things: what is supervised, what is unsupervised, and what is reinforcement, right? Supervise is what? Supervise is a sort of learning that means under certain supervision, in one word. Now you might think, what is under certain supervision, right? What is under certain supervision? Like you are learning as of now is under my supervision. Okay, I am supervising your learning, so you are learning. Okay, so it means I am first making you learn. How am I making you learn? I am giving you certain data through my screen sharing. Okay, I am sharing my screen, I am sharing my audio. So basically I am feeding certain data in your mind. So that's how I am giving you certain data, that is I am making you learn. Okay, or I am training you. After this thing, after feeding you or after giving you some sort of data, what I'm doing, I'm giving you assignment. Okay, so you are doing certain assignment, and as you are doing certain assignment, either you are doing wrong or you are doing right. If you are doing right, then I'm acknowledging you. If you are doing wrong, that means I am making it correct. Okay, so it's not like that. If I am making you correct, suppose you did certain wrong and I am making you correct, once I make it correct, it is not like that again you will do the same mistake. Definitely will not do the same mistake in the next part when you will get the same kind of situation, because you learned. The same thing happened in a machine. We make a machine learn based upon what? Based upon two things. Or what are those two things? Those two things are features, or you can say independent variables. Okay, independent variables and labels. What is this? This is called dependent variables. Right? So basically with supervised learning, what we do, we just make a machine learn based upon features and labels. Features is called independent variables and label is called what? Dependent variables, right? So based upon these things, your machine will learn first. based upon the rules that you will define. And what are the rules? The algorithms. So based upon your rules, based upon the features and labels, your machine will learn. Thereafter you will give a machine certain assignment based upon some unknown feature. Okay, using certain unknown feature, you will ask a machine to perform certain task. Okay, thereafter machine will perform two things. Either machine will perform, if either machine will perform correctly or it will perform in a different way. That means two options machine will have. Okay, it will perform the task and give you the correct output. It is giving you correct output, or it is giving you what? Incorrect output. Two options your machine is having now, right? So if it is giving correct output, okay, then, or incorrect output, whatever output it is giving, you have to compare the things and you have to calculate the accuracy score. That means you have to calculate how much, if it is giving correct output, then how much accuracy it is showing up. How much accuracy means what is the percentage of accuracy? Like 80% correct output is there. Okay, 90% correct output is there. Okay, your 100% correct output is there. Okay, so this thing we have to calculate. Okay, how this thing you do? Suppose you are using 50 unknown values. Okay, if you are using 50 unknown values, and using these 15 unknown values, machine is giving the prediction, or you can say machine is giving an output. Why it will give output? Because it is already trained. Okay, it is already trained based upon features and labels, based upon past data set. Okay, so that's how it will give you the output. Suppose the correct output it is giving is 40, and incorrect output it is giving is 10. That means the accuracy is what? 80%. Okay, now the question is, what is feature and what is label? Feature and label is nothing, it is just about, you can say, feature and label is just a something that is called independent variable or dependent variable. That means you are having a data set, right? Suppose you are having a data set like this. Okay, having a data set like this. Okay, in this data set you are having three columns, right? And what are these columns representing? That I will tell you. This column is representing, like first column is representing your attendance in a class, how many class you attended, right? This thing is represented by this one column. Second column is representing how many assignments you completed. Okay, so this is a second column that is representing. And third column is representing what? Third column is representing your marks. Okay, got it? So it's like attendance, suppose you are having in classes, out of the total, suppose 50 classes are there, out of 50 you have attended 45 class. Okay, or it is the data of someone old student, like some student who is already passed, you can imagine like that. Someone is there who had attended, out of 50 had attended 43 classes. Okay, then there is person who attended 39 classes. Okay, then we have a person who has attended 41 classes. Okay, and someone is there who attended 47 classes. Okay, so this is your attendance. Second one is your assignment. Someone had completed, suppose total assignment is 15, someone had completed 13 assignment. Okay, then 10 assignments, or you can say 10 assignments, right? This person had completed all 15 assignments. This person had completed only 9 assignments, and this person had completed total 13 assignments. Okay, that are marks. Marks, suppose 100 marks is there, he got 80 marks, he got 78 marks. This a person got 86 marks. This a person got 90 marks, and this a person got 92 marks. Okay, so this is the data we are having. Okay, attendance, assignment, and marks, right? Means we have a person who had, basically we have a data set of a particular college, school, or anything. In that data, this attendance and this assignment will be considered what? This will be considered your features, or you can say independent variable. This will be your feature, or you can say independent variable, right? This is going to be your feature, or you can say what? Independent variable, because these are going to be independent. No one is going to control how many attendance that you have to attend, or a person have to attend. A person will decide. Okay, how many assignments that he have to complete, that the person will decide. That means these are independent variables. So based upon this behavior, his marks is coming up, his marks is showing up in the exam. Okay, so as per the attendance, as per the assignment, a person will get the knowledge, and based upon the knowledge some marks is coming to him. So this is called dependent variable. Okay, so this is a data that a class or you can say college institute is having. In future, if one wants to predict, if some person is there who had completed 41, or his attendance is 41, and had completed total assignment 12, then what marks should he will get, or what will be the predictive marks, what will be the predicted marks that he is going to get. So this kind of learning is known as what? Supervised learning, or you can say supervised machine learning, in which two things are very important. One is feature, another one is label. Based upon features and labels, you make a machine train using certain algorithms. Once machine got trained, you will use that trained model to predict certain unknown value. Okay, in between these two things, that a process is go on, that is called validation. Through validation, you validate how much percentage of accuracy your machine is showing. Okay, in the validation part, you use certain data, you use certain value whose output you know but the machine don't know. Okay, if the machine don't know, that means your machine will give a prediction, you will compare the output with a real value and calculate the validation. Is there any kind of a doubt you are having? Anyone having any doubt? Anyone wants to know anything? What is supervised learning? Is it clear? Supervised learning means learning under certain supervision. It can be a software that will supervise, or it can be a human that can supervise. Okay, supervise means what? First make it learn, then make it correct, then make it work, then make it correct, then again make it learn, then again make it correct, then again make it learn, then again make it correct. The labels are the values, right? The labels are the values. The labels means, suppose you are having a data of a company, like sales data. Okay, so sales data will be like what? Like a company had a expense, certain amount of expense in advertisement, certain amount of stores are there, some amount of employees are there. Okay, so these all are independent variables. Okay, these all are features. And what are labels? How much sales the company is attending. Okay, how much sales a company is getting. Okay, how much profit a company is getting, how much loss a company is getting. That are the labels, that are the dependent variable. Okay, like there is a, you have to make a model for a stock market prediction. So in the stock market, the stock price is what? A stock price is label, and all the things that is affecting that stock price are the features. Got it, Parthiv? Okay, anyone having any doubt? So this kind of learning is known as supervised learning. Means a supervised learning will have both the things, features as well as labels. Okay. Next is called your unsupervised learning. What is unsupervised learning basically? Sorry. Oh my god, it is also removing. Anyway, so this is your. Then come to the part that is called unsupervised. Next part is known as your unsupervised learning. What is unsupervised? Unsupervised learning is the case where you are having just feature. There is no such label present. Okay, you are having no labels present, you are having only one thing, only one entity, that is called feature. Now you might be thinking, how a machine will learn only with the features? Okay, only with the features. So in this case, you can consider a data that is present with Netflix. Okay, that is present with Amazon. Okay, that is present with any store like Shopper Stop. Okay, with any store. Okay, that is present with Facebook. Okay, so this kind of data, if you thought of, what kind of data do they have? If I consider Netflix, what kind of data Netflix is having? Netflix is having a data with a feature like your ID. Okay, next thing, uh, the genre episode that you watch. Okay, what, and then we have a age. Okay, the genre episode that you generally watch, the language that you prefer. Okay, how much time are you spending? Time is spent over the platform. Okay, during the time, what is the ratio that you spend upon different languages of show? Okay, like you had watched 10 minutes to a comedy show. Okay, 20 minutes to a kind of a what that is called, crime based show. Okay, 2 hour for something else. Okay, so that is how much time you spend. So you can see over here, in this kind of data there is no label. Okay, is there any label? If I have to make prediction, is there any label over here? If I have to make a, if Netflix needs to recommend you a show, suppose Netflix wants to recommend a show to you, so is there any label over here? There is no such label. Same thing if you consider Amazon, Flipkart, there also there is no such label. If they want to recommend a product to you, how do they recommend? There is no label. Shopper Stop, if they want to Shopper Stop run a kind of what it is called, marketing strategy, or you can say marketing message, so they are having no label. Okay, so this kind of things can be sorted out by unsupervised learning. In unsupervised learning, we are only have features, different sorts of features are there. And what exactly happen, it happens like this. I am considering now only two features. Okay, I will not consider more than two feature as of now, because two feature, it is really easy to draw two feature. Okay, so it's like, suppose because of two feature, these are the points, feature one on x-axis, feature two on y-axis, feature one x-axis, feature two on y-axis, right? So how did it happen? Okay, so this is there. So what does the unsupervised learning do? Unsupervised learning basically find a way to relate the similar looking elements and form a cluster of those elements. Unsupervised learning, what does the unsupervised learning do? Unsupervised learning find a way to separate the similar looking elements and form a clusters of those elements. It just find a relationship between similar looking elements, right? That means all age group, all person who are watching same genre, all person who are watching same sort of languages, all person who are like spending same amount of time over the platform will be there in a one group. Okay, through unsupervised learning, what happened? Clusterings used to be done. Okay, unsupervised learning makes a machine to form different sorts of clusters, and in those clusters, the elements that are present will have same sort of, or you can say same nature of kind of a features. Those features are quite close to each other, you can say quite relatable to each other. Got it? Unsupervised learning. Any doubt? Just think of it. Just tell me if you're having any doubt. And based upon, generally it is used in, mostly it is used in recommendation engine. Okay, means the platform recommends you certain product, certain show, certain things based upon this unsupervised learning. Like Facebook, on Facebook you get a friend's recommendation. Okay, they used to recommend you friend. How are clusters formed? That only we have to study, right, Akhila? How are clusters formed? That is called algorithm. Okay, right. Just like recommending a video on YouTube and all those things. How does the clusters form? That only we have to understand, and we'll make an algorithm so that clusters can be formed. In future we'll see how can we make algorithms so that a clusters can be formed. Got it, Akila? That is the algorithm that we have to study. Right now I'm just defining. Yeah. So this is unsupervised learning. Now third type of learning is known as reinforcement learning, right? So what is reinforcement basically? Reinforcement type of learning generally used in most common example is this one, that autonomous car. Okay, autonomous car, or you can say a self-driven car. Okay, how does that work? That works on a concept of two things. Okay, first is called reward, and second is called reward, and second is called what? Second is called punishment. You can imagine like this: if you are working good, right, that means you are driving nicely on a road, wearing a helmet, there will be no punishment given to you. Okay, there will be no one who can punish you that you are wearing a helmet or something you are doing. So that is, if you are not wearing a helmet and you are driving on a road, so what happens, there will be punishment imposed over you. Okay, there will be a charge imposed over you. Okay, so that is a punishment. So with the punishment, what happens, next time you will always wear a helmet, or will you will always wear a seat belt. Okay, so this is called what? This is called reward and punishment kind of a system. Okay, so that means if something your a machine is doing good, machine will be rewarded. If something machine is doing bad, machine is will be punished. Now you'll see how a machine is going to be rewarded. Machine will be rewarded with the concept of grading. Okay, if machine is performing well, machine will be given a positive grade. If machine is performing bad, machine will be given a negative grade. Right? It will be given a negative grade, right? You got it? So that means if a car is running on a road, right? If a car is running on a road and on running, it is working like it got some kind of a speed breaker. Okay, and with the speed breaker, it fails to de-accelerate. It fails to de-accelerate properly, and it just got a jerk more than the threshold value. Okay, what I'm doing, I'm just making a car learn. I'm just training a car. Training phase is going on for a car, or for a machine. Training is going on. So algorithm is designed like that. If the jerk sensor senses a jerk more than the threshold value, that means that is a negative grade for the car or machine. So the this thing tell the machine that next time, if it is going to operate on a speed breaker, then it needs to de-accelerate more smoothly. Okay, so de-accelerating more smoothly will be like more positive grade will be awarded to the car. And if positive grade is awarded to the car, that means car will know, or machine will know, that it is performing well. If negative grade is awarded to the car, that means it is performing not well. So this is how complete algorithm needs to be designed. This is called reinforcement type of learning. Okay, so I hope definitions are clear for all these types of machine learning. Is it? Definitions are clear for all of you? Any doubt with the definitions? Deployment will be the later part, but any doubt with the definition? Yeah, right, Shreyans. Reinforcement is something which is self-evaluating its performance. Self-evaluating its performance, that is how reinforcement works. But for that only you have to set certain threshold value, certain parameters you have to define. Okay, because without defining any parameter, we can't make something to evaluate itself, right? So it depends, requirement to requirement, case study to case study. Somewhere we need to work with supervised, somewhere we need to work with unsupervised, somewhere we need to work with reinforcement, like that. Did it? Okay, so I continue for the next part. Next part, we'll start first the supervised learning, right? We'll take a small example of supervised learning and we will do it, right? So let me define supervised learning and then the types of supervised learning. Okay. Look, supervised learning basically divided into two types. Supervised learning is divided into two types. What are those two types? First is known as your, what are those two types? First is known as your classification. It's a fundamentally it is divided into two types. First is known as classification, and second one is known as regression. Means while we are doing through the supervised learning, we have to make a machine train in two different ways, either classification or either regression. Okay, so what is classification and what is regression? As the name suggests, classification is something in which you have to make a model that can predict category, prediction, predictions of a category. This is called super classification. Okay, and what is regression? Regression is prediction of a continuous value, right? Just a minute. Okay. Regression is what? Regression is also a prediction. Through regression also you make a predictive model, but here we go with a prediction of continuous value. Okay. Prediction of a category and prediction of a continuous value. Two things are there. Okay. So it's like through classification, we just make a model that can predict something in a continuous way. Okay. Sorry, in a categorical way. Categorical way means what? Just like we created, we had given an example last time. So in last time, there are two things. Marks. Suppose you are going to make a model to predict marks. Okay. So marks can be what? Marks can be like 60.7. Okay. 72, 73, 85, 92, okay, 80.7. Okay, so this can be marks. Second is something that is called a model you can make that can predict in this way result status. What is result status basically? It can be pass. Okay, the result status can be what? It can be pass, it can be pass or whatever, right? Or somewhere it will be fail. Okay, 73 is not fail. This is a different scenario, right? Don't assume that 73 is fail. Somewhere it is pass. Okay, somewhere it is again fail. Okay, somewhere it is again pass, right? So you can make two sorts of model. One model that can predict the marks and another model that can predict the result status. Okay, so if you're making a model that can predict the result status, so in this status are only two, either pass or fall. Sorry, either pass or fail. Okay, so that means you are making a model that can predict a category. Okay, so this type of model is known as what? Classification based model. Okay, this type of model is known as what? Classification based model. That means you are making a model that can predict a category. Okay, and second type of model in which you are which is basically meant to predict a continuous value. Okay, is called what? Regression type of model. So ultimately we concluded there will be two types of modeling. One is called classification based modeling, second is called regression based modeling. For classification based modeling, the prediction will be in the form of category. Okay, it will be a categorical prediction. For regression based modeling, it will be a continuous prediction. Like if I will consider another thing, if a company needs to predict that they will be in profit or they will be in the loss, that is a classification based prediction. They are going to be a profit, they are going to be in the profit, or they are going to be in the loss. That is a classification based prediction. But how much profit amount or how much loss amount, the figure, the amount, that will be a regression based model, right? So for both the models we will work with different kinds of algorithm. There are different kinds of rule for that. Okay, so according to the problem statement, we have to proceed, we have to select which particular thing we have to work upon. It totally depends upon the problem statement. Clear? Any doubt for anyone? So for marks prediction, yeah, regression, right? Marks prediction, regression based model will be used because that is a marks, that is a continuous value. From 0 to 100, it can be any value. It can be decimal value. It can be it can be a float value. Okay. So the range, or you can say the category, is not fixed. Okay. The amount of category is not fixed for a marks. It can be of any part. It can be, like, you can say almost for different cases. It can be from 0 to infinite, anything. Okay, but for status the category is fixed, either fail or pass. Out of these two categories there can't be any other thing. Whatever you data pass, whatever the data you pass, it will just give you either two output, either pass or either fail. It is not going to give you the any third output. Okay, so if our output category is fixed, that is a classification based prediction or classification based modeling. If our output category is not fixed, that is a regression based modeling or regression based prediction. Then, any doubt? Anyone, any doubt? Please ask. If it anything, whatever I had given, you are having any sort of doubt, please ask. Otherwise, we'll proceed for the implementation kind of thing. No? Okay, proceed. Got it, Shreyans. So anyone else having no doubts, right? So we're going to take a first example. This will be example of yeah, well, both examples will consider classification and regression. Okay, I will give you two data set. Just download the data set and then we'll discuss about it. I have given a link. Just download this data set from this link and upload into your and read it. Read it in your working area, right? Whatever the like you are using Jupyter or whatever things you are using, just download and just read it the data. And this one also. Okay, I have shared two data. Just download this data and read this data. Okay, and once you download and read it, just tell me. Then after I will tell what to do. So this is what this is our first hello world program for machine learning. Most simple program, most basic things that we are going to do, right? So I hope you will understand it. Just read it. Once you read, just tell me you did it. Thereafter we'll proceed, right? Great, Shreyans. So you can see in this data what basically we have to do. We have to make a predictive modeling. Okay, if you just create a predictive modeling, right? So how are you going to do? That only I will describe. I'm giving you 2 more minutes. Just read the thing, and in next 2 minutes I will start. Yeah, I am starting now. Okay, the thing is, we have to understand a classification technique, right? So basically, in this data, what we are having total 6 column. Out of 6 column, first column is of waste, that is just the ID. Okay. Then we have a 4 column. Those are the features: sepal length, sepal width, petal length, and petal width. Features of what? Features of a flower. Okay. There is basically a flower, right? Okay. There is basically a flower, and on that flower, we are having what? We got just simple 4 features. Okay. Okay, there can be sepal and there can be petal in the flower, right? So the data is showing what? Sepal length and sepal width. That means this can be the sepal length and this can be the sepal width, right? Then we have petal length and petal width. I'm sorry. It's like anything can be, a petal will have length and width. So based upon sepal length, sepal width, petal and petal width, what happened? It has been categorized. It has been categorized into a particular species. There are how many species present? How can we find out? We can find out by the knowledge that we have already, by the data analysis knowledge that we are already having. So how many categories are present? We can find out by iris and then species, right? This is our species, right? Species S is capital. Okay. So with the species part, you can find out what? How many categories are present. How can you find out? You can find out by unique, right? Dot unique. Okay. Iris setosa, iris versicolor, and iris virginica. These are the categories we are having. Okay. So next, what process we have to do? We need a label, and we know label should be what? Mathematical value. Okay. So how can we get the mathematical value? By using the mapping. Okay. So how can we do the mapping? You can do the mapping by first you have to pick the value of this particular thing, iris species. Okay. Iris species dot map. This is very important because if it is a categorical value, you need a categorical mapped value. Okay. So I'll pick it. Right? We'll map it 0. Second one will be what? Here is versicolor. This will be mapped with 1. And third will be what? Here is virginica. And this will be mapped with 2. You got it? Execute it. You can see mapping is done. Now this mapped value you can store where? You can store in a particular variable named y. Got it? So it is what? It is your labels, right? This is your labels. Next, I talked about features, right? So what will be the feature for your machine learning or this supervised learning? Sepal length, sepal width, petal length, and petal width, right? So we are having what? Iris. Now y is your label. Now you're generating the features in X. So how can we generate? Either we can select these 4 or we can drop these 2. So how can you drop these 2? By using drop function. Drop. What you have to drop? You need to drop ID. And secondly, you need to drop what? Species, right? You will drop it. It will show error not found in axis. I told you what is axis actually. Axis, that means you are dropping on something column. So that's why you have to define axis equal to 1. If you are dropping a row, the axis will be 0. Axis will be 0 for a row and axis will be 1 for a column, right? So we got it. We got this thing. Okay. And we can store this value here. We can store this value in X. Right? So this is what feature, right? X is what? X is your feature. Y is your label. I hope this is clear for all of you. Is there anyone who is having any doubt in this? What we did? Any doubt in any part? Whatever we did? No? No doubt. If any one of you is having any sort of doubt, you can ask. Whatever we did, if there is no doubt, then you can tell again, like no doubts, it's all done. Partha is having no doubt. That's nice. Anyone else is having any doubt? It's very simple thing. I don't think we're having a doubt. So next thing we have to discuss is what? Training. How are we going to train a model, right? Training. So for training, what we need? We need algorithms, right? So from where algorithm will comes up? Look, we are having a way. Either we can develop an algorithm or we can use a scikit-learn framework. Okay. So there is an algorithm for classification. Actually, there is not a single algorithm. There are a number of algorithms. Okay, there are a number of algorithms are there. Okay, we will discuss one by one each algorithm. So first algorithm that I want to discuss with you is KNN. This is one of the most popular algorithm in classification technique, and it is one of the most successful also. Means it gives you a very high accurate result. Okay. So what does KNN mean? Let us discuss. KNN is something. The full form of KNN is known as what? The full form of KNN is known as K nearest neighbors, right? This is also known as K neighbors classifier. This is also known as K neighbors. Both name we can call it K neighbors classifier or K nearest neighbor. So what does it mean? It works on a concept of neighbors. Works on a concept of neighbors means what? Suppose you asked me a question. Okay, you just asked me a question. So how I am answering the question? There is nothing in my mind. I will just calculate a distance of all the person around me. Okay. Suppose there are 10 persons around me. So I will calculate the distance of all the persons around me. So based upon the distance, I will compare, okay, there must be a certain person who is very close to me. So I'll go to that person and I will ask him, okay, what should be your answer? So whatever answer he will give me, I will respond the same answer as it is to you. This is a concept of k-neighbors classifier for a machine. That means you just put a question to a machine. What type of question? Means you just make a machine to predict something. Okay. So how a machine is going to predict? Machine will predict. It will calculate the distance, because suppose you are just putting a question. That means you are passing a feature. Okay, like you had passed a feature ft. Okay, and you are asking, please give me output. It is a setosa, it is a versicolor, or is it a virginica? What is this? You are asking a machine. Okay, so what machine will do? Machine will just calculate the distance of this ft from all the existing points. How many points are existing? You can see we are having 150 points existing from 0 to 149. So total points existing is what? 150. So it will calculate the distance from all these 150 points like this. This is the KNN algorithm. All 150 distances will be calculated. Okay. So out of these 150 distances, there must be one of the distance which is very close, which is known as the nearest distance, right? Nearest distance. Got it? So whatever the output of that nearest distance, suppose that nearest distance is saying it is a setosa, or the label of that nearest distance is setosa. Okay, so it will say ft is also a setosa. This is k nearest neighbor. Okay, this is how k nearest neighbor works. Okay, so now the question, how this distance is going to be calculated? Is there any rule for calculating the distance, or is there any way to calculate it? Yeah, there is a way to calculate a distance. For example, here we have a 4 parameter. I will consider just 2 parameter at first, so that we can get the things clear, right? Okay, suppose these are the samples we are having. Okay, these are the samples, for example, we are having. Yeah, someone is asking, there is a doubt. What's doubt? Sir, may you please explain again? FT function? Yeah, I will explain. Don't worry. FT is not a function. FT is a sample. Okay, I will explain everything again. Aditya, just look here. So what I'm going to explain, I'm going to explain a k nearest neighbor, right? So k nearest neighbor is what? These are our previous sample. Okay, just like your flower sample, we are having just two type of data. Okay, and these two type of data is having certain features. So those features are being defined within the coordinates. We are assuming those features are defined within the coordinates, right? So this is having feature 3 4, this is having feature 2 comma 4, right? This is having feature what? 4 comma 6. Just I am assigning some random feature. There is no such rule of it, right? Some random feature I'm assigning, that's it. Please don't consider like it is at 4 comma 3 or something, right? Anything is at any point. I am not sure who the coordinates. I'm just defining some random feature. Okay, so this is a random feature I am having, right? So that means 3 comma 4 shows what? A star. 3 comma 7 is cross. Okay, you can see 3 comma 4 is what? 3 comma 4 is a star over here, right? 2 comma 4 is a cross. 5 comma 6 is a cross. 9 comma 8 is a cross. 3 comma 7 is a cross. 4 comma 6 is a star. So a star is what? A star is a label, and this is a feature. Okay, now you just make a model, and in future, suppose a question mark comes. Now you have to tell, is this a star or is this a cross? How can you tell, or how machine can tell? Okay, there is a question mark. Now, as per machine learning, your machine should tell, as per artificial intelligence, your machine should tell or itself by doing certain calculation that a star, this question mark is what? Is this a star or is this a cross? It is a star or it is a cross? How it will tell? It will tell using an algorithm. The algorithm is known as KNN, that is k-neighbors classifier. Okay. So with k-neighbors classifier, you have defined number of neighbors equal to 1. That means it will consider nearest one neighbor. So this question mark is actually ft. Okay, this question mark is ft. That means ft is not a function, it is a feature. Okay, feature of certain unknown value. Okay, ft is feature of unknown value, because question mark is what? Unknown value. Okay, so this particular question mark must have certain feature. Suppose the feature is, I'm defining as some any feature, like I'm defining as 3 comma 9. Right, it is having a feature, this question mark is having a feature 3 comma 9. Okay, so basically what this 3 comma 9 is it a star, is it a square, what is it? So there will be a distance calculated from this point to all the given points like this, this. It is calculating a distance, right? From all the given points, it is calculating a distance. Okay. So once the distance is calculated, thereafter it can compare all the distance. As it compare all the distance, if the value of number of neighbors is 1, what it will do? It will pick the nearest one, and the nearest one is what? This 3 comma 7, that is cross. So it will tell, okay, I am also a cross. So your machine will predict this thing as a cross. Okay. So this is how distance, based upon the distance calculation, something is predicted. Now the question, how the distance will be calculated? Distance will be calculated using a concept of Euclidean distance, right? What is Euclidean distance? You will see over here. So 3 comma 9, suppose distance is calculated like this, 3 comma 9 or 3 comma 7. So it will be 3 minus 3, okay, plus x minus x plus y minus y. Okay, so 9 minus 7. This is your first distance, right? Second distance will be what? This is how all the distance will be calculated, right? 3 comma 3 and this all thing. Second distance, suppose it is calculating from 5 6. Okay, just a minute, just wait. So this is the first distance it is calculating from here to here. Now suppose second distance it is calculating. This is the first distance. Okay. Now second distance it is calculating from here, 5 and 6. Okay. So what will be the formula? The formula will be, as you know, 3 minus 5, okay, plus what? 9 minus 6. Now here the challenge appears. What is the challenge? In first case, the output will be 3 minus 3, okay, equal to 0. 0 plus 9 minus 7 equal to 2. In the second case, the output will be 3 minus 5, that is minus 2 and plus 3. Minus 2 plus 3 will be equal to 1, right? So the problem with the second case is like, you have to operate over minus value, that is minus 2 and minus 2 plus 3, right? You have to operate over minus value. That is a big problem. Okay, that means in the distance calculation you can't go with a negative value, because negative value, what negative value will do? Negative value will decrease the value. Okay, so here what we do, we use a square of the values. Whatever the values are there, we have to use the square of those values. Means you put a square over here. Okay, you put a square over here. Okay, and thereafter, after putting a square, as the value is getting enhanced, or it is getting enlarged. Okay, so putting a square solve a lot of issue. Like there might be a situation that 2 points will be at the same distance, okay, because of negative, positive and all those combinations. But with a square, this thing also get minimized. Means 2 points will not have the same distance. Next, it will be a square root. Why a square root? So that magnitude can be decreased. Okay, so this thing is known as what? Euclidean distance. That means, what is Euclidean distance? Euclidean distance is like to use x I minus x xi minus x whole square plus yi minus y whole square. So after this, based upon the nearest distance, suppose there are 150 samples, so your unknown value, please listen me very carefully. If there is 150 samples in your data set, 150 samples in your data set, so your unknown value will calculate 150 distances. Unknown value unknown value for prediction will calculate what 150 distances. Unknown value for prediction will calculate 150 distances and compare those. Right? This is how algorithm is working. And after this, consider n number of nearest samples. Why n number of nearest sample? Because it can consider one sample, it can consider two sample, it can consider three sample, it can consider four sample. If it is considering one sample, then whatever one is telling, it will follow that thing. If it is considering two sample, whatever two is saying, it will follow that thing. But if you are working with a kind of a two category, please don't use two sample, because there might be a one will tell one thing and another will tell another thing. Okay, so if it is then it will go for the three samples. So with three sample, what will happen? Out of three, two is saying star, one is saying cross, it will follow the major voting. It will say I am also a star, because my two nearest one is saying star, that's why I am also a star. If it is considering five sample, it will follow whatever three item are saying, three four item. Suppose three nearest is saying star, or three nearest is saying cross, so it will say I'm also a cross. Four nearest is saying cross, so I'm also a cross. Five nearest is saying a cross, so it will say I'm also a cross. So this is how a machine predict using this kind of algorithm, that is called KNN. Got it? So this all algorithm basically you can program as well, but how you can program, that will discuss later on. First we'll discuss how to deploy and how to make predictions using this KNN, right? What if two distances are same? Okay, look friends, distances are not going to be same over here. Okay, this is a very rare condition that you can imagine, that if two distances are going to be same, in that case only the algorithm will fail. Okay, and in that case it will be a certain, because the points that we are going to use are the floating point, right? The points, the features that are basically a floating type of feature. Okay, just a minute. The points that we are going to use is a floating type of points, so it is not that much that this kind of simple points. Okay, and in any case the features are going to be a, it is not going to be a single feature, the multiple features are going to be possible. Okay, so it's like, at, if suppose one distance is 5, second is also 5, so after 5 it will use point also, like 5.2.3.6 like that. So up to second point decimal, third decimal, fourth decimal, there must be a certain difference. Okay, up to 2 3 decimal it will just get into a, because it is not integer. If it is integer, then we can imagine that okay, there can be a equality happen. Since it is not integer, floating, so in float it is very less chances that two distances, because these are working on a different coordinates. So if it is on different coordinates, then obviously two distances are not going to be same. Still, if it will happens, then in that case, oh, as per the algorithm, it will, you can say the algorithm fails over there. That's only we can say, because it is not being defined. Like if two are equal, then what it is going to do? If two are equal and both are saying same thing, same label, okay, suppose two are equal and both are saying same label, then nothing to worry. Okay, if two are equal and both of are saying different labels, then you can say it will just pick the first one as a prediction, just like your normal comparison like we did in the data analysis. Okay, in that case we don't know the prediction is correct or not, so we can only imagine that the algorithm fails. But this is not a real condition, it is just imaginary condition that we can imagine. Okay, so this is how it is going to be used. Now the condition how it is going to be deployed. For a deployment, all the calculations and all those things we'll understand in the later part, means how to make those calculations possible through programming, that also I will explain to you. But as of now we are going to use scikit-learn framework. Okay, what is scikit-learn framework? You can just see the thing, scikit-learn documentation, scikit-learn documentation. Here is a classification thing. So here all the things are mentioned, whatever the algorithms are there in the classification it is mentioned. Right now I'm considering what? Nearest neighbor classification, right? So this is nearest neighbor classification. In nearest neighbor classifier I am considering k nearest neighbors, one of the algorithm. So how to use it? It will be mentioned over here. It will be mentioned over. This is how you can use it, right? Got it? So from official documentation you can get how a particular algorithm is going to work. Okay. Just wait. Number of neighbors is defined as 3. I will remove it. So how to train? This is the definition of an algorithm through a library, through a framework. And thereafter you can k model dot fit. Dot fit is what? It's a training of a model, right? Training a model, okay, for prediction. Okay, so this is training of a model, right? So how to train a model? You can train a model by using x comma y. Okay. So by default, it is considering how many number of neighbors? 5 number of neighbors. This you can change by putting in this parameter, right? Thereafter, k model dot predict. What is this k model dot predict? K model dot predict will be used for predicting a value. Okay. So for predicting, what you can do, you can pass certain parameter like 2.1, 3.2, 4.3, comma 5.4. Okay. So this is your first parameter you can pass. So this will be predicted with as certain value. Here also I can pass certain value. Here's a prediction. It is a 2, it is a 0. 2 is what? 2 is something that is known as Iris virginica, and 0 is something that is known as Setosa. Got it? So what we understood? How to use framework, how to use define a training, how to define a model, and how to predict. So what is remaining now? What is remaining now? How to validate my model? How to validate my model? How to visualize data points on x and y coordinates. How to visualize data points on x and y coordinates, right? Next thing is remaining, how to decide which parameter are most can be most preferable. Which parameter we can prefer more? That is, can we reduce number of features for training, right? Or next thing will be also how to decide how many number of neighbor is how many number of neighbors can predict with best
possible accuracy. So there are certain questions that we should understand. How to validate my model, what is the training accuracy or what is your prediction accuracy, how to visualize between x and y axis, okay, like cross and star that we drawn, how to decide which parameter we can prefer more, that is can we reduce number of features. Number of features means right now we are using how many features, 4 features. So is it possible to use only 3 feature or 2 feature, okay, because if you use less number of features, so it will be like less amount of calculation will be made, means less uh, consumption of things will be there. Whatever the things it is getting consumed, it is consuming what? It is consuming some amount of processing power, right? Some computational power. So whatever the computational power it is consuming, so if it is a 4 feature, it will consume more computational power. So is it possible to decrease the requirement of computational power? It is possible. So is it possible to decrease the number of features from 4 to 2 or 3? It is possible, but the question is which feature should we consider or which feature should we not consider, okay, and then decide how to number of neighbors, right? We should use one number of neighbor, two number of neighbor, 3, 4, 5, which one is better, okay? So these all things we have to discuss. You should complete it, and I think this we should discuss tomorrow for better understanding. Is it right? Shall I discuss this thing tomorrow or today only, because I guess this much is enough for the today. You should work with it, and we'll discuss this thing tomorrow, like with a classification, and then we'll go for the regression part, right? You also note down the questions. In these questions you should note it down, okay, because tomorrow as I asked like what I have to start, you can just tell me because I might forget the questions, right? So you can just note it down so that you can ask me like these questions we have to solve over the modeling. That is it. You can just practice the things that we have studied today, just have some kind of learning and all, and tomorrow we'll start the session and then we'll solve these questions. Anything, any doubt need to ask? No? No? Okay, man. Thanks a lot. So shall we conclude? Shall we conclude the session? Okay, one thing I want to tell you, like on Saturday and Sunday, you might have to take the session in the evening, right? Like from 7 to from 7 to 9:30, 9:30 or 7 to 10. Okay, from 7 on Saturday and Sunday, right? So please keep your scheduling like that. Okay, on Saturday and Sunday only, right? Because I have certain tasks, certain things to do in my certain. So this time I will not be free. So upcoming Saturday and Sunday, just schedule your things like that only. Okay, so that you will not that's why I'm telling you right now, because all of a sudden if I'll tell you, then it will be quite tough to arrange the things, right? 6 to 9, okay, that time only, around 6 to 9 or 7, we will make it, right? I'll make it from 6 to 9, right? Because in the evening only I will limit, after 6 I will get free. Okay, after 6 I will get free, that's why I told the time 7. So I will try to make it start from 6, like as I get free I will just start the session, right? Thank you, take care.